Okay, so now we learned about levers, and now we're going to calculate the actual or the ideal mechanical advantage of a lever. This is very similar to the ideal mechanical advantage of an inclined plane or the ramp. As you recall from earlier, the IMA the formula is distance in divided by distance out. Now, as we recall, in a simple machine, in order for a simple machine to work, you have to increase the distance, which will make the force a lot less. So the larger our input distance, or the longer that we have to work with for the input, the more advantageous our simple machine will be. So if we take an example of a rock that has to be lifted and using a lever, this is the fulcrum, and I am pushing down here. If this distance is 1.5 meters, and this distance is 0.5 meters, I can calculate the ideal mechanical advantage of this lever. IMA is equal to distance in divided by distance out. Distance in is the distance from the fulcrum to where I am putting in the effort. And this distance is 1.5 meters. The distance out is the distance from the fulcrum to the actual object, or to the output force, and that is 0.5 meters. Therefore, the ideal mechanical advantage of this lever is 1.5 meters divided by 0.5 meters equals 3. What does this 3 mean? This 3 means that it is 3 times easier to lift this boulder with the lever than without it. Or, in other words, it requires 3 times less amount of force in order to lift it. So let's give an example. What if this weighed 200 kilograms? That's a heavy boulder. Remember, mass is not really good in physics, so we need to convert these to forces. So the mass is 200 kilograms. Well, we need to find the actual output force that it is pushing on the ground. The output force, is the same thing as its weight, because that's the force that the boulder is exerting on the earth. Well, Fg is found by multiplying mass times the force of gravity. So Fg equals 200 kilograms times 9.8 meters per second squared. With our calculator, we calculate 200 times 9.8 meters per second squared, and I get 1,960 kilograms times meters per second squared, which is shortened to a Newton. Now remember, we found that the IMA is 3. This means that it is 3 times easier to lift this boulder if I use the machine. So my F in will be equal to F out divided by the IMA, or F out divided by 3, because it is 3 times easier to lift it. Well, we learned before that F out is the same thing as its weight. So F in, what I need to put in, is 1,960 newtons divided by 3. Using the calculator, if I divide this by 3, I get that I need about 653 newtons of effort. 653 newtons of effort. So as you can see, using a lever, I need much less force, but I need 3 times the distance. This is how you solve a problem using the IMA of a lever.